All right, looking at our next lesson here, comparing linear functions in different forms. A little warm up to get started. Determine whether each set of ordered pairs represents a function and explain your reasoning. So if we remember back to our first unit, we talked about a function. To be a function, we can only have one output for any given input. So in other words, if we're looking at a set of ordered pairs, we cannot have repeating x values, repeating input values, unless they have the same output, because then it's the same point. So if we look at each one of these, for number 1, the x's are -1, 0, 1, and 2. Those are all different, so that is a function. Same with number 2. The x's are -1, 0, 1, and 2, so that is a function. Third one, also the same, -1, 0, 1, and 2. Those are all different, so that is a function. But on the fourth one, all the x's are -1, so we have lots of repeating inputs with different outputs, so that is not a function. All right, getting started activity says choose and justify, or choose the function that does not belong with the others and justify your choice. So there's lots of different options you can go with here. There's no right or wrong answer, or I should say there's several right answers. Just a couple examples of reasoning. The first one, you could say with a table, that is the only decreasing function. Only decreasing function. For function B, the verbal one, that is the only one where the domain is just whole numbers, because if you think of saying during 1 year at Belfield High School, the ratio of boys to girls was 1 to 1. Obviously, you can't have 1.5 of a boy or a girl, so the domain is only whole numbers. And that is the only function that's like that in this group. For function C, the equation, it's the only one that the slope is between 0 and 1, so it's created a function that's flatter than the parent function. So this is the only slope between 0 and 1. And then function D, that's the only one that actually has a y-intercept that's not 0. All the other ones have a y-intercept and initial value starting at 0. All right, so moving on to activity 1.1, or 8.1, I should say. It says determine whether the graph of each linear relationship is parallel, perpendicular, or neither parallel nor perpendicular to the graph of 4x minus 3. All right, so starting with A, the table. What we need to know about each one of these is the slope. So the slope of A, this is going up 10 for my y values, and this is going up 2.5. So if we divide 10 by 2.5, that has a slope of 4, and we're comparing it up here to a slope of 4. So A would be parallel. They have the same slope. For B, an elevator descends at 4 feet every second. So the descending part makes this slope -4. So that's not the same as 4, and it's not perpendicular to 4, so this one would be neither. For C, a slope of 1/4. That's also going to be neither, because remember, to be perpendicular to a slope of 4, we'd have to be an opposite reciprocal, so the sign would need to become negative. And then for D, again, this is another one with a slope of 1/4. So again, that's neither. It's a reciprocal of 4, but not an opposite reciprocal. And then for E, to find our slope, our y value is going down 1, our x value is going up by 4. So -1 over 4 for our slope, and that is an opposite reciprocal of 4. So this one would be perpendicular. And then the fourth one says, for every hour Chiletso bakes, she makes 4 dozen cookies. So that's a slope of 4, which is obviously the same as 4, so that one is parallel. All right, activity 8.2. Large recycling center pays out different amounts per ton of cardboard recycled. Washington County Recycling Center lists its payouts amounts in a table, and Jackson County uses a graph to advertise its payout amounts. The two centers' payout amounts are close but not equal. All right, so what we're going to be doing here is comparing these in these few questions and deciding which one gives us the better opportunity as a customer. Okay, so number one, each representation shows a functional relationship. So we don't have any repeating inputs with different outputs. So there's no payouts at these that are different. The label the quantities and the units in the table of the graph. All right, well, for the table, obviously the left column is your x's. This is our independent value. It's our x's, which is the weights. And the y column is your dependent value. This is I'm just going to put a money sign. It's our payout. Okay, very similar to the graph. The x column or the x-axis is our weight. It's our dependent or our independent variable, just like the other table was. And then our y column, again, is our payouts. Again, I'm just going to put a money sign for our payouts here. Okay, for 2, let W of x represent the function for Washington County and J of x represent the function for Jackson County. Use a greater than, less than, or equal symbol to complete each statement. So we're going to compare each one for a weight of 0.5. Well, change colors here. For Washington County at 0.5, the payout is $7.50. On the graph, if we follow 0.5 up, that looks like the payout is at 10. So that means Jackson County is greater than Washington County, or Washington County is less than Jackson County. Now they want to look at a payout of 1, so $15. At Washington County, a payout of 1 on our graph here, follow that all the way up, is at $20. So similar again, Washington County is less. Jackson County is greater. And then for C, looking at 3. Now, if we follow the pattern here, 3 is going to be up we're going up by half, so we're going up 2 rows here. So if we're going up $7.50 per row, it's going to go up another $15 before we get to 3. So 2.5, and I'll say 3 here. So by the time we get to 3, we're going to go up another $15 from 30. So we're going to be at 45. And if we follow 3, obviously as we follow that up, we're going to see this line go up higher and higher. We can see it's going to go much higher than where 45 is. So again, we have the same result, which is expected, even though we can't quite see that on the graph. We're talking about a linear relationship here. So if the other two have Jackson County being greater than, we can expect every input value for either one for Jackson County to be the greater than output value. Okay, for number 3, it says compare the y-intercepts of each relationship. What does each y-intercept mean in terms of the relationship between the quantities? The y-intercept on both is 0. And all that represents is that there's a $0 payout for 0 weight. Let me erase that. I get a little sloppy there. For 0 weight, which makes sense. You don't bring them any weight to get paid out for, they're not going to pay you anything. And then for number 4, which recycling center would you choose? Obviously the one that has the greater payout, and we can see from number 2, all the payouts on Jackson County are much greater. So I'd go with Jackson County just because it has a better payout. All right, activity 8.3. Activity 8.3, comparing equations and tables. Josh and Greg are friends who live in different countries. When they chat online, they talk about weather. One of them always uses temperature in degrees Celsius, while the other talks about temperature in degrees Fahrenheit. So Josh uses an equation to convert Greg's temperature, and Greg looks at a table to convert Josh's temperature. The equation and part of the table are shown. Okay, so for number 1, identify the quantities in the table and equation. Who's converting from degrees Celsius to degrees Fahrenheit? Who's converting from degrees Fahrenheit to degrees Celsius? All right, well, we're looking at Greg's table. His left column is his degrees Fahrenheit, and his right column is the degrees Celsius, because degrees, when we make the conversion, degrees Fahrenheit is greater than degrees Celsius, so we can tell that is how his column is labeled. And for Josh's equation, he's multiplying whatever his temperature is by 9/5, so he's making it bigger. So he's taking his x value, which is his degrees Celsius, and converting it to degrees Fahrenheit as his output. So Greg is going from degrees Fahrenheit to degrees Celsius, and Josh is going from degrees Celsius to degrees Fahrenheit. Okay, the number 2, compare the given characteristics of each function in terms of slope and y-intercept. Well, Greg's slope from the table, if we were to calculate change in y over change in x, we are going to find that his slope is 5/9, and that Josh's slope is 9/5, which makes sense that they're reciprocals of each other because they're taking the same units, and one's converting from degrees Fahrenheit to degrees Celsius, and the other one's converting from degrees Celsius to degrees Fahrenheit. Okay, for the y-intercept, Greg is approximately negative 17.75, which means 0 degrees Fahrenheit, which means 0 sorry, my screen messed up. Let me scroll back. There we go. Which means 0 degrees Fahrenheit is equal to negative 17.75 degrees Celsius. So as I was mentioning earlier, degrees Celsius is much lower than degrees Fahrenheit, so that conversion makes sense. And then if we look at the opposite, Josh, his y-intercept is at 32. Which means 0 degrees Celsius is equal to 32 degrees Fahrenheit. Okay, and that is the conversion. When we're freezing and our Fahrenheit temperature we measure here in the US, 32 degrees, that's equal to 0 degrees Celsius, which is freezing temperature in Celsius. All right, and then for 8.4, Michelle and DeAndre both opened bank accounts at the same time. DeAndre's bank account balance is shown in the graph. He started with $0, deposited the same amount each month. In the 4th month, he had $80 saved. Michelle opened her bank account on September 1st with $25 and continues to deposit $25 each month. All right, so looking at our graphs here, we see DeAndre's graph, Michelle's description of opening her bank account on September 1st with $25 and is depositing $25 each month. So it says, use what we know about DeAndre's account to determine the scale of each axis. Well, we know he ended up with 80 after 4 months, and that graph's showing 4 deposits. So we can assume this is 80 here. And if that has to be 80, each one of those deposits has to be equal to 20, 40, 60 to get to 80. And then we know his deposits were happening each month, so we can say this must be the 1st month, 2nd month, 3rd month, 4th month. Okay, so there's his scale of his graph. That page update, there we go. So we got the scale of each axis, we did our explaining of it. Number 2, compare the given characteristics of each function in terms of the slope. Well, for DeAndre, his slope, since he's going 20 each month, is 20. So that just represents $20 each month. Michelle, her slope is 25. She's depositing $25 each month. And then for the y-intercepts, DeAndre has a y-intercept of 0 because he started with $0. But Michelle has a y-intercept of 25 because she started with an initial amount in her account of $25. So her graph would start, if we were looking at the graph compared to DeAndre's, her graph would start, I'm going to put a red dot where it is, up here, compared to where DeAndre's is starting down there.